Hey everybody, my name is Melisha McGregor, and today we're back with another DevOps Fundamentals. So today's topic is chaos engineering, and we're going to go into a little bit of detail about what chaos engineering is and why we would use it in DevOps. So to just jump right into it, chaos engineering is this discipline that lets you run tests on your system that mimic turbulent conditions. So basically, what you get to do with chaos engineering is pretend you're unplugging a bunch of wires in the server room, or maybe you're pretending a raccoon got in the room and they're unplugging wires and chewing through things to find whatever raccoons look for in wires. But the gist of it is chaos engineering lets you figure out how your system is going to react to those really random kind of natural disasters or the hardware failing or just things that you can't usually account for in your software. And the main reason you would want to do this is that your application is cloud native, like almost all applications are now. So you have to account for your cloud service provider being down along with your application having its own issues. Remember, these cloud service providers also have their own technical issues sometimes. And it doesn't matter to your customers whether it's your fault or the cloud service provider's fault. They just know they aren't able to access the application. So you would want to include chaos engineering in your DevOps practices to make sure that if anything happens with your cloud service providers, you have some kind of method, some kind of procedure to fall back on to make sure that your application still works for your users. Now that you have an idea of what chaos engineering is and why we would use it in the first place, let's talk about the most important part of chaos engineering, and that would be talking. So, chaos engineering means that you purposely go into your system and break things to see what happens. And a lot of people don't like that. Nobody likes it when you go into the system, when you go into the code, and you just start breaking things. People don't want you to break their stuff, and chaos engineering does just that. So, another reason that people don't want you to go in and break things is because we never want to admit that our systems can fail. It's something that every system, online, offline, wherever, every system can fail. The thing is, we need to accept that that's a part of the process and that systems can fail. It's better for us to go ahead and break things before the real problems happen. But you might get people that are just like, I don't see the point of this. And you'll have to convince them of the usefulness of chaos engineering. And the way that you do that is you show them how susceptible your system is to failure, whether it's because a tornado hit an AWS server location, or maybe some malicious ex employee came in and just deleted everything that you need to run your server. This is why it's so important to make sure that you're talking to everybody involved with your DevOps operations. So, the main way that you're going to convince people to get on board with chaos engineering experiments is to start by finding the steady state of your system. And that means you get to take a really good look at your application. So, do some extensive monitoring. Include different services that let you know when errors happen or when outages occur. Work with your DevOps team to make sure that all of the possible things that can go wrong with your application are at least being monitored. And once you have all of this monitoring, all of this data about your system, it gives you a really good idea of how your application currently works. So you'll figure out things like what the CPU load is normally and what your regular throughput is. This is stuff that typically in DevOps it's not just really looked at until it becomes a problem. So, monitoring is one of the foundations of chaos engineering experiments. If you don't know your steady state, you can't figure out when your application or when your system deviates from the normal state of things. Of course, there are a lot of free tools, a lot of paid tools, a lot of services that let you run chaos engineering experiments. And one of the most popular ones would be the Chaos Toolkit, where basically you can go in and work on it just like you would a science experiment or a chemistry lab. You'll create a hypothesis about your system. So you'll think about things like, if the server in this region goes down, will the other server regions provide enough resources to keep my application running? So that might be a hypothesis you have. Then you can go ahead and run that experiment. Of course, you won't be shutting down an entire region of servers, but you can pretend that a server in a specific region you use has gone down. And then once you've run this experiment, you can go ahead and evaluate those results. And the results will show you just how much your application or your system deviates from that initial steady state. So this is how you find out where your application or where your system weaknesses really are. This is where you can do things to make sure that you have the kind of resilience as Netflix or as any other large service like Amazon itself. When you finish these experiments, your results will basically tell the story for you. So, all of those people that you had to convince in the beginning that the system wouldn't fail, now you have proof of what actually happens when a part of the system goes down. And of course, there are other tools like Chaos Monkey, Gremlin Free, and if you're working with Kubernetes at all, KubeMonkey. All of these tools run under the same premise of you have a hypothesis, you run an experiment, and you evaluate your results. And those results, of course, will tell you exactly where your system might need a little bit of help. Maybe you need to funnel more resources or get more CPU space or whatever it is you need. So now that you have just kind of a really quick overview of what chaos engineering is, a few things you might want to consider are exactly where to run these experiments. It's probably not the best idea to try to convince people to run these things on production. There's so many things that can happen in these experiments that you probably don't want your users to know about. So if you set up just a separate environment, maybe you use staging, maybe you have some other just separate chaos engineering environment for your system and application. But the main thing you want to make sure of when you make this separate environment is that it is as close to production as it possibly can be. That means including the same number of resources, using the same services that you normally would. Just make that chaos engineering environment as close to production as you possibly can. Of course, you don't have to leave this environment up after you run your experiments, but it's great to know that if or when a hurricane floods out an AWS center or a fire takes down a GCP server, that your application and your users won't experience any downtime, or you'll have some kind of fallback plan for that downtime. So hopefully this gave you a really quick overview of what chaos engineering is, why we use it, and how you can get started with it. So we'll see you next time.